with effective condition monitoring, presented today by Will Leonard and Marianne Yturbo. Just a little bit of housekeeping before we get started. Will, you can go to the next slide so that you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop. Control panel hides automatically when not in use, so you need to move your cursor over to bring it back. You have the opportunity to submit text questions to today's presenters by typing your questions into the Q&A box of your attendee interface. You may send in your questions at any time during today's presentation, which will last about 30 to 35 minutes, and we'll collect these questions at the end and address them at the very end of the presentation during hopefully a lively Q&A session. If you cannot locate the Q&A in your meeting controls, then click on the controls button with the 3 dots, then click Q&A. This adds the Q&A box so that you can type in your questions. Additionally, throughout the presentation, we will have a few quick polls where we'd love to participate with you alongside us. And as a reminder, all the attendees are on mute today. Today's presentation is being recorded, and we will be providing you that here shortly in the next couple of days for your reference. Next slide. So today you'll hear from me, Samantha Spano. I'm the Global Product Marketing Manager for ABB's Digital Solutions. Will Leonard, he's our Global Portfolio Manager for ABB's Asset Performance Management portfolio. And Mariana Yturbo, who is our Condition Monitoring Product Management and member of our Digital Customer Engagement team. Their contact details will be provided after the presentation, and we would very much welcome hearing from you to understand how you're implementing predictive maintenance strategies on your sites and what barriers, if you see any, in reaping the benefits of a predictive maintenance approach. So now I'll pass it over to Will to get us started.
Great, thank you very much, Sam. So, seeing the path to predictive maintenance, what's it all about? We're going to have a look at some of the main drivers for a predictive maintenance strategy, process for getting there. We're going to have a look at where you can actually start in that process, the types of systems that you can leverage to support you in achieving your predictive maintenance goals. And then, as Sam said, we're going to be doing some polls throughout the presentation, so please keep watching the screen throughout. So we're operating in an unprecedented environment right now due to the global pandemic. Output has fallen significantly in many industries, including chemicals, for instance. Oil prices have significantly fallen as demand drops, and any expectation that they're going to return to normal levels in any time soon actually seems highly unlikely now. Rather, we'll be in a position of lower for longer and a kind of new period of a different normal. Some of our industries are undergoing a fundamental shift. Some in the chemicals industry, for instance, are repurposing their plants now to produce much needed items like hand sanitizer. And in the power sector, lower demand for electricity in the UK has resulted in the longest ever period of not using any electricity generated by coal, a truly remarkable period in history, UK sector. So in the industries that we work in around the world, and particularly in the US, have been directly affected, both plants onshore and offshore. They have to adapt. 90 to 95% of office personnel are working from home all over the world, and maintenance teams are on much reduced hours. So planning and preparation for maintenance and turnaround activity is clearly becoming more difficult. There's no access or limited access to some key resources, whether that be people, drawings, recordings, equipment information, and there's limited access also to the plant for many people. So for projects or equipment overhauls, that makes that very different right now. And critical long lead items are also becoming unavailable from other countries. Plans may have already been disrupted, and it's time really now to replan in a lot of situations. So, but that regulatory burden, that legislative burden still remains. So there's a significant challenge right now to adjust expenditure, protect businesses, lower operational costs, and asset integrity, safety of the plants across industries. So this is when we're going to do a first quick poll. I want to find out from attendees here today, how many of you are changing your plans for turnarounds, inspections, maintenance activities? So if we can launch the poll. So you currently postponing TARs or equipment inspections? So you can answer yes, postpone the shutdown, yeah, postpone inspections and maintenance, maybe postpone the shutdown, or maybe postpone inspections and maintenance, or doing business as usual for you. Okay, so we've got some results that are going to be coming in, I think, shortly on that. All that everyone will be able to see. So this is really about the changing landscape. Okay, so it looks like only 6%. Not changing any plans at all, so continuing as normal. So 94% are doing something. It looks like actually more than a third are looking or have already postponed a shutdown or postponed inspections and maintenance. So difficult times clearly at the moment, difficult times ahead as well. But one thing to consider, I guess, for us is for those companies without things like online monitoring of the condition of their equipment, the risk profile in making that decision has just shot up. And further, what information is available to support the decisions to delay or postpone the activity? It becomes incredibly difficult, almost working blind on condition of some assets. So extremely difficult. So thank you for sharing your feedback there. So, of course, in the domain of asset reliability, the underlying reasons for change, have always been there in maintenance spend. The cost of downtime is huge in our industry, and we're already regularly talking to people from existing plants looking to lower their operational costs, deal with availability issues and equipment failure. But in the energy industries, of course, there's a lack of experience, growing skills gap, aging equipment, and plants operating beyond their intended life. There's an increasing need to actually rely on systems to inform those decisions, and remote expertise for support as well. Maintenance is really one of the biggest areas of both direct foreseen cost as well as sudden unforeseen cost in our industries. And using predictive analytics, condition monitoring, combination of expert and data science models, you can deliver predictable operations, reducing cost and improving productivity. So it sounds like from that last statement, technology alone is the answer, but actually it's much more than that. In the background here, you can see a picture of a Formula E car. ABB did a lot of sponsorship around Formula E, and a while ago I was fortunate enough to spend some time with a few people from the McLaren Formula One team, actually. And it was hearing about their operation, the operational model for races and the step change in performance that I think was really helpful in thinking about improving our own performance in energy industries. So, for example, taking a look at technology, they need to know the condition and the performance of the car and its parts. So they've built diagnostics into that equipment clearly, and they've also added some additional sensors. So in Formula One, things like you can get data from obviously everything on a car. So they could add 1,000 sensors if they really wanted to get everything possible. Or if they're really concerned about weight and aerodynamics, then maybe they could limit that to as minimal amount, so 50 or 100. Instead, of course, they look at what is critical to the operation, what's critical to performance, and then how they're going to use that data. They decided that the optimal amount of sensors they needed to add on their Formula One car, in addition to those built into equipment, was 250. They did think about technology in a big way. But then they also thought about people. So trackside and remote support Remote support is done from the UK actually, so the race is going on anywhere in the world. So you've got 12 people who are handpicked in a remote support centre, and they've got 3 people with a job title of race strategist. So you kind of think top mechanic, you think maybe ex-racing driver, but no, that person was actually a data scientist, and they were 24 years old, and that's because the person running that remote race strategy needed to be able to quickly understand all that data and use those tools to inform the decisions and feed back to trackside. And they were 24 years old because they did some research and found that the brain is at its optimal level for solving mathematical issues at age 24. So they handpicked the right skills into the right places. So they thought about technology and they thought about people. But then what about process? Well, they have these extremely quick feedback loops. Their strategic round is just an hour or an hour and a half. And so they're remotely supporting these race decisions from anywhere in the world. They've got track support, pit crews that run a very, very lean process, highly innovative ways to use data and make those improvements in real time. So technology is really important, but technology alone is not the answer. Definitely part of the solution, but operations and the overall maintenance philosophy also has to change to reap the benefits. When we're looking at operational performance, so what can we do? We've established a 6-step framework for your journey, and we're going to take you through 50% of that story during today, and then we're going to finish off the other 50% in the next webinar that I'll tell you about later. So the first step is to understand where you're at with the processes and equipment. This may involve taking the data that actually already exists on the plant and visualizing that information to support decision making. Really, it might be about using everything you've already got available on the plant. Once visibility has already been established, the next step is to close any gaps that exist where information could be lacking from critical assets on the plant. And here, additional data points could be added to gain deeper understanding of asset condition. And then you might want to put that into that condition data from disparate systems into a single dashboard to have a better view of overall equipment health, operational insights in one place. And then it could be about choosing the right type of analytics. So many approach predictive maintenance with a pure data science approach now. We believe that a combined approach of using data science where data science can be useful, as well as expert model or heuristic reliability engineers models is more effective. Choosing the right method is key. And then learning and adjusting those, learn and adjust the operations accordingly. And then establishing that reliability culture, the way things happen around here is really important. So with that introduction to the process, I'm now going to hand over to Mariana to start the journey.
Thanks, Will. So hello everyone. So this is Marianne talking. So the first couple of points in Will's in the setup that Will presented just now is about data. But why are we talking about data? So traditionally, maintenance is calendar based. For instance, that you change the part every couple of years, and that's logical as long as we assume that failures are correlated with time. What we see on this slide is a summary from a study that went through other studies that had looked at how failures on equipment were distributed over time. So for instance, if the failures are occurring mainly at the beginning and at the end of the equipment lifetime, we would expect the equipment to fall within the first row in this table. So following this bathtub curve, as you can see in as illustrated on the curve number A. However, what we see is that most of the failures or most of the equipment have failure curves that fall within D, E, and F. So, and in those curves, it's more or less random at what point in time most of the failures occur. So if time is not necessarily a good way of estimating when a piece of equipment is in need of maintenance, then what do we do? So that's when we talk about data. But first, before we go in a little bit more into that, I think there's another coming. So this poll is a group of questions where you have to try to describe your maintenance practices, so whether they are calendar-based, condition-based, predictive, usage-based, or run to failure. So there should be 4 questions on your screen on the side here. All right. It's so I think the poll is closed, so let's wait a minute for the questions, or for the answers to come through. So this is to have a look at kind of how you are planning maintenance currently. All right, so what we see, so here we see that quite a lot of you guys have, or most of the answers are really on that the maintenance is mainly calendar based, as far as I can see here. Could also be that you have not had a chance to answer the last couple of questions, but I think, I mean, mainly calendars based is probably also the fact for most sites though. So thank you for sharing. So, but let's have a little bit of look into then if we are not necessarily using time, or if we wanted to use something else than time to plan our maintenance, then what would be needed? So if you have a look at the next slide. So what's needed, and this is mainly or probably also known information to most, but it's sometimes useful to to be reminded, at least for me, I think it's useful sometimes to be reminded of the steps. So, I mean, you need a fault condition that's detectable. You need to, in some way, be able to see that the fault some fault is about to happen, as we can see some examples on the in the graph on the right-hand side. So examples here include noise, they include vibrations, for instance. And we also need some form of instrumentation that allow us to pick up that fault condition. And we also need some form of information about the progression towards failure. So again, that's what's illustrated in the black lines here, is that so how fast would we expect a functional failure after we've detected some condition like smoke, for instance? And finally, also, as Will has already been talking about, it's also about having procedures and strategies in place that allow us to take advantage of this information. So well, typically we say that, well, then we need to start with data, and very often we can start with data that is already available. But when we do that, it's also important, or there's usually more information available than at first glance. So here's an example. If, for instance, in a historian that you would have some value for some pump, and here it says a motor with edge insight, so that we would uh, collect information with a software package that we offer that's called Edge Insight, where we also contextualize the data. So we also bring in metadata like units, ranges, descriptions of the tag, and contextual data like on where in the system this is located, as well as set points from the alarm system and from the control system. So I guess the message here is more that it's you usually have a lot of data already available in the site that you can take advantage of, and using modern software you can also collect the context information for that already available data. Another example of what we can do with already available data, we can have a look in the slide. So this is an example from a site that had some condition monitoring system on their MNSIS switchgear from ABB, and purchased a condition monitoring system from ABB, but they hadn't really started using that information in the system in their maintenance plan. So for that switchgear, they were using 909 offshore work hours every year. I think you can have some clicks on the slide here. And then what they did was going through all of the inspection maintenance activities and check whether that activity was there to observe something that was already covered by the monitoring system. And the result was quite significant. It was they were able to remove 882 offshore hours every year, so move that to the onshore location. So that's also illustrated in a figure now, where so basically then it was only 3% of the maintenance activities that was still performed offshore by an electrician. So, but sometimes there's also information. Sometimes we may need more information that's already available in our systems, and then we're typically talking some form of instrumentation. So for electrical equipment, that's very often some form of intelligent device. So what we have here is an illustration of an IED, a drive monitoring device from ABB, and a transformer monitoring device from ABB. But often also like temperature sensing, motor sensing for cabinets are common and useful. For rotating assets, obviously, online vibration monitoring is kind of typically what's synonym to condition monitoring. At least it has been. But there are also several wireless options on the market, and ABB also offer wireless vibration and temperature sensors that can be used for most rotating assets, especially ones where there's no need for critical shutdown functionality, obviously. These also with new sensing technology coming out and wireless technology coming out, and such sensors are becoming increasingly intelligent and also increasingly cost effective. And then finally, as we've already talked a little bit about, the control system has a lot of information already, and also it's also often important to monitor like networks and switches in addition to monitoring our electrical and rotating assets. Finally, telecom equipment can also help bring a full picture into the monitoring systems. So if we look at the next slide, we see a bit of an overview of various types of sensors and devices offered by ABB to collect different types of data and monitor different types of equipment. And we also offer software solutions that for orchestration, analytics, and visualization. So now it's time for another poll. So now we've talked a little bit about types of condition monitoring systems. So the question here is, what types of systems are you using for condition monitoring? So online condition monitoring for most equipment, online condition monitoring of highly critical equipment only, no online condition monitoring, or no condition monitoring. How the poll is closed. So here we wanted to see a bit about potential and what kind of monitoring is already out there. Yeah, so here we see that almost or more than half has answered that you have online condition monitoring of highly critical equipment only. So there may then there may still be potential, right, to add extra access to data. But of course, this always has to be added if you think that that would information that would be used to potentially change the maintenance plan. All right, now let's have a look at the analytics, so kind of step 3 in the framework that we started with. So in the system, we solve different tasks on different levels of the network, and different types of analytics also belong on different levels in the network, as illustrated here. So on the component level, the most important task is obviously protection and control. On system level, we can work more on diagnostics. On plant level, maybe even prognosis. And on fleet level, we can utilize data for more type of strategic planning. So what's typically described as condition monitoring on the device and component level, often like simple fault detection. But to enable early fault detection and diagnostics, you typically need to integrate data from connected equipment and integrate on system and plant level. And then the root cause analysis, the maintenance optimization as written here, that requires integration of the data on the plant level. So you want to be able to look at data from more than one equipment, maybe, because the cause of a failure is not necessarily related to just one piece of equipment. And but then to further enable predictive analytics, we need to, as already discussed, when we looked at this beginning here with the failure curve progression, so we need to improve the access to condition data on component, system, and plant level. And we also need, so on the component level, we need to have fault detection and diagnosis type analytics. So something that's indicating that a failure has occurred or is about to occur. But then on system and level, we can have analytics that more accurately pinpoint the root cause, and especially when the system is highly interconnected, that even if you observe a fault on rotating machines, it could really be related to your electrical systems, right? And then we want to add analytics to estimate likelihood of or frequency of events and enable machine learning technologies. But then that requires obviously large amounts of data, and it also, but that's what needed to build out these potential failure to functional failure curves, as we saw in the beginning of the presentation, to really learn what these curves look like for different type of equipment and different failure conditions. And then fleet level data can also be used to try to build out predictive analytics and also to compare different maintenance routines across different plants. So how ABB builds out our condition monitoring system, we base them on something we call asset monitors. So if we can have a look at that in the next slide. So these asset monitors, they're software pieces that's built out to fit a piece of equipment with subunits and maintainable items. And then they also include then definition of the failure types monitored. And each failure type then has there's analytics for detection of the failure types, including thresholds and then severity definitions, where severity is also based on the criticality of the equipment, and also decision support. So what is the probable cause of this failure condition? What would be a suggested action? Go ahead. And we visualize this in faceplates and dashboards for different levels and for different user types. So if I have a look at the next slide, this is something that ABB has delivered for several or for a long period of time. So to the leftmost side, we see an example for that we'll also talk a little bit more about later, but it's an EICT delivery where it's a monitoring system for the full plant and for all the different systems, but then integrated into the control system. We've also gradually then moved that with also offering more office level applications available to onshore personnel. And then now moving towards offering this as cloud-enabled services that allow for a high degree of collaboration between product experts, field service, customer experts, and also interaction between the ABB Ability cloud system as well as our customer's cloud system. So with that, I'll hand it over to Will to go through some examples of deliveries we've been part of.
Thanks, Mariana. So this first one actually builds on the one that was just presented, the Goliath example. So this is a fairly new asset. So they had the advantage of really thinking about the whole operating concept from the outset and building condition monitoring and understanding asset health condition really into the design. And therefore, they've managed to achieve with ABB in partnership across a wide range of condition monitoring scope. They're covering rotating equipment, control instrumentation, and a huge range of electrical equipment all the way down into the subsea system as well. And so, as I say, it's a bit different from having to get that coverage across that broad range of equipment. Really, to get that into the design, it's really important. But then that can, of course, lower the overall operating costs then for assets throughout their whole operation of 10, 20, 30 years. So they have the system offshore, but then it's also replicated onshore for support. So they can minimize the amount of people that are offshore. It's in a very remote location that's obviously hard to reach. And then compare that to then a retrofit, essentially, of condition monitoring solutions. So in the BASF example, here we're starting to look at a broader range of rotating assets across many plants. So here it's about improving plant reliability, optimizing the maintenance and spares and the overall efficiency of the machines. They already had condition monitoring systems on the highly critical equipment, much like the audience here that just answered the poll. But actually, they were also spending a lot of money on the lower medium criticality equipment that they had hundreds or in fact thousands of. So it's really about targeting that class of equipment and looking at how condition monitoring could apply there. And then compare that to, again, a retrofit. So this is an existing installation. So this is a Nel Green Power. They wanted to understand how they could adopt predictive analytics or predictive maintenance strategy across a number of plants. So we successfully delivered a pilot to them a couple of years ago, and they've now decided to extend that to a deployment across 33 plants based in Italy. And here we're covering a range of equipment such as the main turbines, transformers, and generators, using a combination then of data science, machine learning models, in addition to the heuristic or the expert models there. So on this slide, you can see three examples. One of a greenfield installation where they could really design condition monitoring and provide the types of equipment that you would need for condition monitoring in from the outset, through to targeting a very specific fleet of motors with sensors and then a system, through to then taking a look at the, again, critical equipment, but using a predictive analytics, using data science, as well as those reliability engineers models, those FMEAs, to improve the reliability and to get fleet maintenance savings. Not only the maintenance savings, but also then increasing or improving the generation capability. Okay, so we've looked at the core aspects of predictive maintenance. The technology alone, or actually adding thousands of sensors on their own, are not going to deliver the savings and improve reliability for companies, but rather it's that overall system, the combination of people, process, and technology that's important. And there's never been a more pressing and challenging time for companies looking to maintain output, reduce cost, and ensure certainty of operation. And it really requires a fundamental shift in the way we do things around here, so that core operating and maintenance practices and philosophy. Choosing the right technology and analytics approaches that are matched to the specific reliability issues on the plant can really help. So we looked at the ways to get started, working with the data that you have, identifying what's critical to operations, where maintenance budget is being spent, what causes reliability issues on the plant. And then we looked at adding additional data points that you might need, and then the different types of analytics add to support maintenance decisions. And what type of systems could help you in that? So before I end, we've really looked at steps 1 to 3 on this journey. So on May the 21st, we complete that journey. So we've looked at gaining visibility of the data, understanding the gaps, remediating them. We've looked at condition monitoring systems, and the next time we're going to get a bit more into the detail about how to choose that approach to analytics. Every day we hear of predictive algorithms, machine learning models, data science, and then there's reliability. We've probably got quite a few reliability and maintenance engineers on this call, and trying to fathom out how those machine learning models, algorithms that they hear about are actually related back into the failure mechanisms identified in FMEA, for instance. How can you trust black box data? We're going to look at some of the technologies in a bit more detail, demystify some of the approaches, and in fact recommend and demonstrate a combined or a hybrid approach to give you the results, data you can interrogate and therefore trust. So as I say, we're going to provide a practical demonstration during that session, and then further we're going to close the loop and look at what it takes to build that reliability culture, and we'll have a reliability practitioner on the call, Connell Brown, who's a senior consultant from our integrity management team, go through some worked examples. So really like you to join that one on May the 21st. Okay, so with that, we've got a chance for questions.
Thank you, Will and Mariana. We will